How's it going? This is your old pal, Mr. Cook, and we are going to work on probably the rest of this page and maybe a little bit on the next page because that's all the graphing stuff. No, you know what? I'll just do graphing on one video. So we'll just finish up this page. So we're given that the sine of some angle measurement is equal to 5/12. We also know that the cosine is less than 0. In other words, the cosine is negative. We need to find the exact values for the other 6 trig functions. You must draw a sketch in the correct quadrant. Okay, well, let's see which quadrant it's going to be in first. I know that the sine is positive and that the cosine is negative. So the only place that happens is in the second quadrant, right? Because the sine value is the y value, so y is the upper quadrants. And then with cosine is negative, that's the x value. Cosine is negative on the left-hand side, so up and left means that we're going to be in quadrant number 2. So the way that you write this up and the way that you solve for the 6 trig ratios is very similar to something that we're going to do down here with these coordinates. What we do is we basically put together a right triangle with a reference angle, okay? Because this angle measurement that we have, sine of the angle, is actually going to have the same trig ratios as its reference angle. So what we can do is just draw out the reference angle. It's basically just draw out a hypotenuse from the origin out to some point, doesn't matter where. And then we just drop our 90-degree angle off of the x-axis, and this is our right triangle. This creates a reference angle right there. And from this reference angle, that's how we get this ratio of 5/12. Remember what sine is. Sine is the opposite side of the hypotenuse. So that means my opposite side is 5, so that goes here. And my hypotenuse is 12, that goes here. So now we just go ahead and use Pythagorean Theorem here. Watch out because this is not a Pythagorean triple. So we use Pythagorean Theorem to find that missing side length. 5 squared plus x squared is equal to 12 squared. 5 squared is 25. 12 squared is 144. If I subtract 25 from 144, I get x squared is equal to, what is that, 119? 20, yeah, that's right, 119. And then this isn't divisible by 3 or anything I can think of. It might be prime, so I'm just going to take the square root and leave it. So x equals the square root of 119. And it has to be either positive or negative on the outside. We'll see which one it's going to be in a second. So that's square root of 119. Okay, now since this is in the second quadrant, that means that all of my y values, in other words the sides that go up and down, are positive, and also the x values are negative. So that means that the side that goes left to right here has to be negative. And now we just go ahead and answer the question that it's asking. So it says to find the exact values of the other trig ratios for all this stuff. So that means that we're looking for, well, let's just write them all down. Sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. All right, so sine is already given to us. That's 5/12. Our cosine should be negative. It is, so that's going to be the adjacent side over the hypotenuse, so negative square root of 119/12. And then our tangent is going to be the opposite side over the adjacent side. So that's going to be 5/square root of 119, and it's going to be negative because of that little negative symbol there. Cosecant is the reciprocal of sine, so I just flip this over, 12/5. Secant is the reciprocal of cosine, so that's going to be a negative 12/square root of 119. And cotangent is the reciprocal of tangent, so I just flip that one, so it's going to be a negative square root of 119/5. So those are my 6 trigonometric ratios right there, and also a sketch of the triangle and the proper quadrant. So that's number 5. Next, we're going to do number 6, find the exact value, do not use a calculator, of the following trig functions. So this is all just going to be, standard recall of unit circle stuff. So the cosecant of 7π/4, we can actually find on our unit circle, believe it or not, because cosecant's not on there, but the reciprocal of cosecant, which is sine, is on there. So what I'm going to do first is find the sine of 7π/4, and then to find the cosecant, I need to do the reciprocal of it. So if you look on your unit circle, or if you just have it memorized, the sine of 7π/4 should give you negative square root of 2/2. So now what we need to do is take the cosecant, which is the reciprocal of this. So the cosecant of that same angle measurement is just going to be the reciprocal of this. So negative 2/square root of 2. And that can reduce down to just negative square root of 2 if you rationalize the denominator, or just, flat out divide it out. So there's your answer, negative square root of 2. Very similarly, we're going to work on the 6b. Cotangent, we don't have on our unit circle, but we do have its reciprocal pair, which is the tangent. So we're going to find the tangent of 3 pi over 2, and then take its reciprocal. And it just so happens that the tangent of 3 pi over 2, if you look on your unit circle, is undefined because it's going to be 1 over 0, the y value, or negative 1 over 0, which would be the y value over the x value, so undefined for that one. But that does not deter us because we know that we're looking for the cotangent of that angle measurement, which is the reciprocal. So if we take the reciprocal of this ratio of negative 1 over 0, we get 0 over negative 1, and 0 over any number other than 0 gives you 0. So 0 is our answer for 6b. All right, so those ones are very similar. They just rely on your unit circles. So just make sure that you know your unit circle values. You will be given a blank unit circle that you can fill out on the test. So, just keep in mind that you can do that. So if you need to memorize how to fill out the unit circle, or if because you haven't done it with your unit circle quiz, then practice that leading into the test. All right, next up, number 7. So number 7, these problems that we have for 7a, b, and c are all very similar. They're solved the same way. They use the same properties. So I'm going to do this one and then kind of fast forward through the other ones. You first start by just graphing out the coordinates. So 2, negative 5 is going to show up in quadrant number 4. I go over 2, then down 5, 1, 2, 3, 4, 5. So my coordinates right over there. So what you do for this, to find the 6 trig ratios from the angle that's in standard position and a terminal side passing through this point, you just draw a line that goes directly over to that coordinate. Then what you do is you draw a line going directly from this coordinate to the x-axis. So this triangle gives you a reference angle, very, very similar to number 5. And these two coordinates now become the sides for your triangle. The x value is 2, it's positive. The y value is negative, it's negative 5. And from here, we can find the hypotenuse by, again, using Pythagorean Theorem. So 2 squared plus negative 5 squared, make sure you put parentheses around it, is equal to your hypotenuse squared. 2 squared is 4. Negative 5 squared is 25. 25 and 4 makes 29, and that obviously is prime. So that means that our hypotenuse length is going to be the square root of 29. All right, so now we got to find the 6 trig ratios. So let's see here. Let's write them out. I don't have a lot of space to do this. Cosine, tangent, and then cosecant, secant, and cotangent. All right, let's see what all these are. Hopefully I got enough room to write. Okay, so sine is going to be the opposite side over the hypotenuse, so it's going to be negative 5 over the square root of 29. And cosecant is the reciprocal, so that's going to be a negative square root of 29 over 5. Yeah, because I'm not going to have enough room to write in all this other stuff. Oh well. Cosine is going to be the adjacent side, which is 2, over the hypotenuse, which is square root of 29. And then the reciprocal of that is going to be the square root of 29 over 2. And then the tangent is the opposite side over the adjacent side, so that's going to be negative 5 over 2. Cotangent is the reciprocal of that, so it's going to be negative 2 over 5. So those are our 6 trig ratios. Okay, you know what? I'm going to do the other two on the back of this little scratch paper here. Yeah, okay. Wait, a different scratch paper. I don't want a big piece of paper to write on. Yeah, that's fine. Okay. So the other one that I'm going to do is, let's see, this coordinate, which is at negative 3 square root of 3. So that's a negative and then also a positive. So it's a negative x value, meaning it's going to go to the left, and then positive y value. So it's going to be in quadrant number 2. So that coordinate, doesn't matter exactly how you write it out. It doesn't even be super specific, but negative 3 and then up square root of 3, it's going to be right here, let's say. So we draw our little right triangle, right on our reference angle, and then the x value is negative 3, the y value is square root of 3. Now we use Pythagorean Theorem to find the hypotenuse. Boy, that sure seems familiar, doesn't it? It's the same steps that we used in 7a. So Pythagorean Theorem, square root of 3 squared plus negative 3 squared equals x squared. All right, and then square root of 3 squared is just going to be 3. Negative 3 squared is a positive 9. 3 plus 9 is 12. And then when we take the square root of that, we can reduce it if we want to 2 radical 3. So that means our hypotenuse is going to be 2 radical 3. You can write it down as square root of 12 if you want, but I might be able to reduce a little bit. Actually, no, it doesn't look like it will, but, oh, yeah, with the square root of 3s, I'll be able to cancel it out. So I'm going to write all these up. So sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. All right, here we go. So sine of theta is opposite over hypotenuse, so square root of 3 over 2, square root of 3. And that just reduces, doesn't it? Because the square root of 3's go away and I just have 1/2. Easy. Now cosine is going to be, let's see here, adjacent over hypotenuse, so that's going to be negative 3 over 2 radical 3. And you can actually reduce that. It looks pretty nice, but I'll just leave it as is. And then we also have the tangent. Tangent is going to be, that's going to be, by the way, like when you reduce it, it'll be, let's see, square root of 3 over 2. Oh, okay, so that means it's a 36 and 90 triangle. That's pretty cool. Anyways, tangent is going to be the opposite side over the adjacent side, so square root of 3 over 3, and it's negative. And then just do the reciprocals of each of these. So 2, and then you have negative square root of 2 square root of 3 over 3. And then the last one here is going to be negative 3 over square root of 3, which reduces down to negative radical 3. Yeah, it's definitely a 36 and 90 triangle. All right, now we've got our last little coordinate there, which is going to be, let's see this on this side. There we go. So it's going to be square root, negative square root of 5, negative 2 radical 3. So when we draw out that coordinate, it's a negative and a negative, which means that it's going to be in quadrant 3. So we draw out our little right triangle. There's our reference angle. The x value is going to be negative square root of 5. The y value is negative 2 radical 3. And then we just do Pythagorean Theorem once again. So negative square root of 5 squared plus negative 2 square root of 3 squared. So let's see, negative square root of 5 squared is going to be 5. Negative 2 radical 3 squared is going to be, let's see, that's 4 times 3, so 12. Oh, yeah, because we had square root of 12 for that, huh? 5 plus 12 is 17. So that means our hypotenuse is going to be square root of 17. So now we write out our sine, our cosine, our tangent, and then our cosecant, secant, and cotangent. Sine is going to be the opposite side over the hypotenuse, so that's going to be a negative 2 square root of 3 over square root of 17, and you can rationalize that if you want. I'm not going to. Cosine is negative square root of 5 over the square root of 17. Same thing there. And then tangent is going to be opposite over adjacent, so it's going to be negative 2 square root of 3 over negative square root of 5, so the negatives cancel out, giving us a positive tangent, which we should expect for quadrant 3. Cosecant, we just take the reciprocal there, so negative square root of 17 over 2 radical 3. Then reciprocal there, negative square root of 17 over square root of 5. And the last one, square root of 5 over 2 radical 3. So there's all 6 of our trig ratios. And we are just like that, all done with number 7. Last one on the page, number 8. So let's see, find the exact value of each. You must show a sketch. Okay, whatever you want. So what they're talking about here is just like for the arcsine or sine inverse, the arctan or tangent inverse, and then the arcsine, which is the sine inverse of each of those. So that's what they want the sketch to reflect. They want you to show the domain and range for each of those. So just to kind of remind you, I'll just fill it out in this space over here. Sine inverse, remember that if you take the sine inverse of some ratio opposite over hypotenuse, we want to only have one value to make it a function, right? Like, because we go from x to 1, this input value leads you to 1 output value. So sine repeats itself in the top quadrants and the bottom quadrants. So what we're going to do is just pick one top quadrant and one bottom quadrant, quadrant number 1 and quadrant number 4, to describe how sine inverse works. It goes from 90 degrees or 2 pi all the way down to negative 90 degrees or negative pi over 2. Did I say 2 pi? I meant pi over 2. That's my bad. There we go. And then for cosine inverse, cosine repeats itself on the left and right-hand sides because it's the x value, so to speak, in the circle. So that means that we only want 1 on the right and 1 on the left. So the easiest way to do that is using quadrant number 1 and quadrant number 2, meaning that the ratios that we're going to use are going to be consistent with just one angle measurement, which goes from 0 degrees, or 0 radians, to 180 degrees, or pi radians. And then we do tangent inverse as well. Tangent, let's see here. So tangent is like sine, in its approach, but the reason that we use it is because we see that like the first quadrant and the third quadrant have the same tangents. The second quadrant and the fourth quadrant have the same tangents. But like if you use first quadrant and second quadrant, you'd have this like undefined value right in the middle. So instead we just use the first and the fourth quadrant like sine. And we use the same values going from 90 degrees or pi halves to negative 90 degrees or negative pi halves. And we don't include those values because they're undefined. And that's the only one that would give you like two of the same tangent values. So that's why we also leave those ones out. Okay, so with all of that said, let's go ahead and work through this stuff. It's actually pretty easy from here as long as, again, you have an understanding of the unit circle, especially for this first one. Because all you need to do is just know what the cosine of 4 pi over 3 is. So if you look on your unit circle, the cosine of 4 pi over 3 should give you, let's see here, that'd be, I'm doing this without a unit circle, pi and then another third, so that'd be 1/2. Yeah, 1/2. All right, and it should be negative because it's going to be in the third quadrant, so negative 1/2. And then we need to do the sine inverse of that. So sine inverse, if we were looking for where, like basically what this question is asking now that you do the part on the side, it says, what angle from 90 to negative 90 has a sine that is negative 1/2? So the one that you should see is the one that goes right down here, because negative 1/2 would correspond with this coordinate right here, and it's 30 degrees down, or pi 6 down. So that means that it's going to be negative pi over 6. And that's an angle measurement, a radian angle measurement that's between 0 and negative pi over 2. So it's going to be in this quadrant, and that's the angle that we get. If you're thinking about it in terms of degrees, it would be negative 30 degrees would be your answer. All right, now let's go ahead and work on this one. When we have an arc tangent or something inside, if it's not using a unit circle value, we need to draw a triangle. So arc tangents can be based off the idea of this domain and range over here. And if it's a positive tangent, that means it's going to take place in the first quadrant, because all of your positive tangents, if you look on your unit circle, are up here. So that means that this triangle that we're going to draw is in the first quadrant. So you draw your first quadrant, you draw your little triangle out of there, your right triangle, just like we did in number 5 and number 7. And then tangent is going to be the opposite side over the adjacent side. So that's going to be 5 on this side, 8 on this side for this angle. So this is the angle that we get from this information. Then we just need to find the cosine of that. So the cosine of this angle is going to be the adjacent side over the hypotenuse. Well, we better find the hypotenuse. So use Pythagorean Theorem. 5 squared plus 8 squared. That's 25 plus 64, which is 89. I believe that's prime. Yeah, that's prime also. So this is just the square root of 89. All right, so cosine is going to be the adjacent side over the hypotenuse. So cosine is equal to 8 over square root of 89. And that's our answer. You can rationalize it if you want. I'm not going to, just because I don't feel like it. This is another problem where you create a triangle. So this is going to be arc sine. So sine is going to be the first and the fourth quadrants. And the place where the sine is negative is in the fourth quadrant. So that means that we're drawing this triangle out from the fourth quadrant. So there's our little right triangle in the fourth quadrant. There's a reference angle. And remember that sine is opposite over hypotenuse. So the opposite side is negative 3. The hypotenuse is 5. Then you can use Pythagorean Theorem. I know that this is going to be a Pythagorean triple, so 3 and 4 and 5. So this side's 4. And I know it's going to be a positive 4 because it's moving to the right along the x-axis, so it has to be positive. So here is our triangle. We need to find the secant of this angle right here. Secant is hypotenuse, 5, over adjacent, 4, so 5/4 is our answer. All right, so that's the end of the first page of the extra review. And I'm going to go ahead and start working on another video for the graphing on the other page. So if you have any questions, don't be afraid to reach out to your math teacher or just, practice some of the worksheets that we have. And that's about it. All right, on to the next video.